I'm really thrilled to be here. It's I'm going to admit that I do have botany in my background as well as zoology, and I feel like I'm a bit of a magpie, so I collect a lot of things. But I'm also guilty because I've only been to about 3 meetings prior to this one of a Wildflower Society, full stop. I'm a bit selective, I kind of come along, but I think that's because of young kids and all sorts of other distractions. So I'm really glad to be here tonight. I'm really glad Christine asked me. However, I'm probably the wrong person to be standing here. As you've heard, this is really Tasman's project, so we're going to swap in a minute and she's going to jump up. I won't do that to you. We talked about this on a trip down to the Fitzgerald on the way because Tasman was presenting. So she recently presented to the Friends group as a bit of a midpoint along the progression of her on her project to give them an update, and it was a good opportunity to kind of meet the broader friends as opposed to a handful of people we kind of intersected with as we got the project together. So anyway, I was thinking about who you were, and I was aware of the immense knowledge collectively and probably individually. I recognise Eddie. You know, I've come to one of the sessions I went to was one of Eddie's because I wanted to skill up in some areas. So that's one thing, but also I'm aware that, you know, we all have different interests, and sometimes it's bankshires or sometimes there's other species. And Hakea victoria is what I would call a charismatic species that I'd never met personally until last year, but I was already aware of it. And so I was thinking, well, most people know Hakea victoria. Maybe this is all going to be a bit of an old story, except whatever Tasman's project can bring to it. So tonight I've got the most glamorous photos I could dig up, because that's always entertaining. Little anecdotes perhaps along the way. There's a bit of science, but I've kept it kind of low key because sometimes the minute standard errors and means and graphs start popping up, some people I know will just kind of tune out and I'll lose them. So hopefully it's going to be a mixed bag and you'll sort of enjoy part of it, if not all. So I guess I should also firmly acknowledge the Friends group. I love this project because it's student driven, and that's where my kind of passion is. I like facilitating, enabling students to do great things, and I can just sit back and watch them kind of go. But it's also the community, and so it was community that kind of selected the project. So they put a call out, the Friends group put a call out asking for people who are interested in contributing to the science of the national park. It's pretty broad. And I happened to be in a room with Byron Lamont. I don't know if you know Byron, the Bankshire guy, and all the rest of it. And we happened to be, I think it was almost the same day they got this email, and I said, oh, if you're going to do a project in Fitzgerald River, what would you do? And he said, oh, you'd have to do something on Hakea victoria, surely. There's very little published, and you know, for such an amazing looking plant, why haven't we done more? Why does the thing change colour like that? What's that purpose? Has that got an evolutionary, you know, basis for it? So I thought, oh, okay, Hakea victoria. I put it out to the students. Hey, Tasman, who said, you know what, I've changed my mind, I don't think I will do honours, suddenly came flying, this is my recollection, suddenly came flying back and said, you mentioned, you know, there was money available to support a small project down on the south coast, and then she went on to explain that her grandparents live in Bremer Bay. She's got an affinity for the location. She wasn't exactly sure where she was going to go, if it wasn't going to be honours, and all of a sudden it just kind of clicked, and she said, oh, I want to do it, and I'd love to do a project. And I said, well, what about Hakea victoria? Apparently it's a good project, and that's how this sort of was born. What I'll do is, because of the number of people, and maybe I just want to ask 2 questions. Number one is, can I see a show of hands who's been to Fitzgerald River National Park? Okay, as I suspect, that's not bad. That's probably about 45% maybe. That's good. And the second question is, in that case, who has physical contact with Hakea victoria? Which is probably the same people who've been down the park. I think there's one in Kings Park, and there's probably a couple in a couple of gardens, right? So you've got time to kind of pass these things around. The thing that you notice immediately, and I'll pick this up a bit later, is that they have quite a texture. So I've got 3 leaves, and maybe I'll throw this in and pass them whichever way you like. I only have, oddly enough, this is kind of ironic, what you've been playing with recently, I only have 1 fruit. And so I'll pass that around as well. Give that to you, Eddie.
You should have told me, Dylan. I have a whole bag.
Yeah, I know. Tasman's been up to eyeballs in about, 200 odd bags of fruit that were collected last year. And we'll come to that in a second. I want to get into the talk, but I suppose I knocked this title together pretty quickly. It mentions the key words, Hakea Victoria, Fitzgerald River and Seed Bank. That's probably the important bit. The timing, to be honest, the timing is in my head. The first thing I think about when I think of this project is fire and the timing of fire, in fact the frequency of fire and the meaning of that for Hakea Victoria. And so in some ways this whole talk is about a case study for one plant of absolute thousands, I can say that, within the national park. And it would be lovely to do the same thing with every plant there, or fill the gaps, if you like, so that we could have the same sort of depth of knowledge that we're gaining from this project to be able to guide fire. All right. I was going to introduce Tasman, it's been kind of done, but just to prove that she has been at the site and up to her neck in some of the scratchiest vegetation you might come across. Traditional sclerophyllus vegetation, some good Hakea Victoria around her. It looks like an older site, Tasman, 33 years possibly, post-fire. A little bit more about me. Christine sort of asked me as for a bio, but she said something interesting about you, and I thought, oh, okay, that's a little bit different, but that's kind of, I find those stories interesting anyway. So I was influenced by growing up in Walpole from year 6 and eventually progressively left as you had to chase schools further afield. And that's the house that is, it looks a lot different nowadays, but it's because it's had a lot more work done since I lived there as a kid. But from the top window there, that's the view. That's Mount Franklin. So that's the Mount Franklin wilderness area, if you like. And so out the back there, that was my, apart from the farmer's paddock here, which we got on to, oh, sorry, I should go back. Can I go back? Don't jump the gun. Press the wrong button. Apart from the farmer's paddock here, essentially you run into the national park pretty quickly, and that was my childhood. And I think that had a lot of influence of where I've kind of ended up today. So that's where sort of I come from. I want to take you to the national park, if you haven't been, in this very split-second video to give you a sense of the landscape. And at the same time, I'd like to also acknowledge the traditional owners, the Whadjuk Noongar here that we meet on, but also the Gorang, Menang and Wajari people. My son, as I was leaving the house, maybe 5 minutes before, said, oh, I heard this interesting event that happened down there where they found the joining of song lines within the park, and there was a project done without getting into it. But it essentially pointed to a location where several clans would probably meet. That was the interpretation, which was quite amazing. And then I said to him straight away, oh, it's funny because, you know, whenever I look to see who are the traditional owners and the elders for this region, I know there's at least 3 groups that are mentioned. So that kind of makes sense to me, what he was saying. So anyway, to pay respects to those elders past, present and future. All right. So first then we're going to start at the park level, then I'm going to jump to the plant, then we're going to get into the science, and then I'll kind of tie it up at the end. So the park is, I think most people who've been down there would agree, but also if you know anything about the southwest corner, you'd probably say biodiversity hotspot, and there are some hotspots. I say hotspots within the hotspots, and this is one of them. It's special. It was recognised as this strange kind of UNESCO label was given to it. Oh, keep pressing the wrong button. The International Biosphere Reserve, and without going into any detail, this goes back to 1978, and it was accepted by UNESCO, and essentially, because I think of its rich biodiversity, but also the potential for human activity around it, and there was what they call cooperation zones and things, talking about how it might interact with agriculture, and a sustainable kind of hub within that corner of the world that kind of had everything going for it. That's my probably very vague and strange kind of interpretation, but that's how I read it. And then in 2016, seems very late, but it got onto the Natural Heritage list in our own country. The landscape is marvellous and unique. When you step into it, the first feeling I got was the wild. It felt like I was in a wild place. This was, you know, you sort of felt a little bit smaller, and you felt also special at the same time because it had values and properties that you couldn't really put your finger on, but it felt nice to be there. the previous photo, there was a craggy rock which was up here. Some little geological facts, and this starts to describe the biodiversity of the place. We've got dune systems, the coast running straight up to it. If we go back far enough, and I'm talking about 1.2 billion years, we've had Antarctica resting up against this coastline. That was part of the reason why it pushed the barrens up. East Barren, Middle Barren and West Barren went up. It eroded horribly down as well, and so there's not much left of them now, so they're quite low lying. But all that sediment, then contributed to what was around it. Jill Craig, who was one of the friends and a botanist, and some of you might know Jill, I'm not sure, but she was we were standing when I took this photo, and she's sort of saying, it's crazy to think that is kind of where the ocean was eroding and lapping at that rock for so many millions of years after, Antarctica was split and left and kind of waved goodbye and left behind. And then if you kind of move this direction, kind of heading, I suppose north, but sort of northwest or something like that, you kind of see landscapes like this, which is old marine sediments. And so at a time when the water was higher, all of this was flooded, and this was a tiny little island, and there was another tiny little island, another, and little, things just hanging out thinking, when's this water going to drop so we can kind of spread our wings a little bit and maybe evolve and become really kind of special for people later on. In there was like a warm ocean, and sponges went berserk, and then they kind of died and fell to the bottom, and more sponges, and so you've got this really strange kind of sedimentary base of some of this area. Then there's lateritic formation in the last 12 million odd years, when it was a bit warmer and wetter in that part of the world and so forth. So my point is that you've got sand plains, and you've got kind of rocky, craggy ridges, and you've got rivers cutting in, and lake systems and swamps, and then you've got a big park, so you've got climate changes. So if you head north, you lose about 100 mils of rain going from the coast to the edge of the park, and then if you head east to west, a similar sort of effect. So you've got wet pockets and dry pockets, and so you've got climatic variation, geological variation, and the whole thing, as we kind of know, a bit typical of the southwest, nutritionally poor. Phosphorus lacking, nitrogen fairly low as well, and so that just set the scene for, I guess, competition, survival of the fittest, the story, and then we get lots of mechanisms to try to survive, and everything can have a go, and everybody wins. There's no big dominant winner because there's piles of nitrogen and something goes, I'm just going to hog it all and grow up shadow, and you end up with a coniferous forest or something like that. So really impressive landscape. And then consequently, as you get down to the ground, you start to look around. Now, another reason why I shouldn't be here, I've already said that the first time I went to Fitzgerald was just last year. And since last year to, when was it, March or wherever we went down last, I probably could count the number of days I've spent near, not necessarily in, but on the park or near the park on two hands, So my expertise of the park is pretty thin. My understanding of the flora is even less, because I'll be there with my camera, and Tasman's kind of heading for the next Hakea Victoria, and I'll be kind of snap, and I've got to come back to that. Look, wow, that's amazing. I haven't seen that before. And Banksias galore. The Banksia inflorescence we saw out there is in the park. It's in that area. I noticed. I took a great photo of my wife's head next to it just to show a comparison. I needed it. No, she's got quite a petite head. But the size of that inflorescence is huge, right? So I need to scale. My keys are going to be too small. You won't even notice. So anyway, Quallup bell, Pomelia, wattles. So you've got Fabaceae represented, Myrtaceae also big, Proteaceae galore. It's everywhere. Hence, particularly the scratchy environment. Smoke bush, leafless orchids, carpet snakes. There's fauna there as well, right? And honey possums, black cockies, and all the works. So it's biologically really impressive. In the scheme of things, it makes up about 13% of the southwest corner. Yet, I kept recalculating this depending on the data you use. And I thought somewhere around 22, I think Jill Craig about 5 years ago said 29. I've been conservative, so let's say somewhere at 25. Let's draw in the middle. 25% of the southwest flora is represented. 75 species are found nowhere else. Hakea victoria arguably is one of those, although Robert Tozer would say, oh, I've got 2. Oh, just outside of the park. And he's right, they're there. We had a look. So it is quite botanically special. But there are threats to the park, and I mentioned fire at the beginning, and I don't look at fire as an enemy. I don't think you can. The fire is a natural part of our landscape. What's maybe the enemy of biodiversity is inappropriate fire regimes. And so fire is not fire is not fire. You know, fire is a complicated sort of beast, or a complicated element that we should respect, but also realise it has a place. And so intensity and frequency and season of fire all kind of starts to speak to this regime, and then so what is it? And for something like Hakea victoria, frequency is particularly important, and we'll get closer to that soon. There's phytophthora risk for the park, there's other canker diseases, climate change obviously couples with things like fire as well, so changing frequencies or intensities potentially. So there are risks, and thankfully there's a lot of good work done by WCA out down there, and they are strict about access to park. If drip of rain, and they're kind of closing gates and monitoring it just because they know what they've got and they know their responsibility. East Mount Barron. You can walk up this thing, fantastic walk, get a great view back to Hopetoun that way, and into the distance Brenda will be somewhere out there, but you can see the other barrens. This is the spectacular plant. I mean, when we drove into the park, I just remember feeling like, where is it? Where is it? But instantly, oh, it's there, and it's there, and oh, hang on, it's not there. And then all of a sudden, another patch. And you'd sort of, it wouldn't be everywhere, but it's definitely there, and it's impressive. It doesn't sort of, it stands out from, if you like, if you squint just a little bit, everything else sort of blends in, but Hakea victoria is still in frame. It's, if you've felt the leaf yet, you'll realise the thing is tough as nails. The dry leaf there is, to be honest, I don't think it's much different to the nice soft leaf up here. I made the mistake on our first trip going down there without leather gloves, and we were starting some field work. Tasman came prepared, she had these bulletproof things on, and I said, you know what, I'll just go down to the IGA and I'll grab a pair. And then I think this was after the first day, and I was gingerly doing things and said, just give me the recording sheets, I'll just be your scribe. and so she got in there and she did all the hard work, and I just scribed away. Bought some gloves. By the end of the trip, I'd shredded them, and they were the toughest things that IGA could offer me at the time. I did make that mistake again, and yeah, you regret it, and you realise that this thing is armoured. It's a sclerophyllous plant, hard-leaved. I'm sure you've kind of heard this language before. Typical of the Proteaceae family, but it's sort of like if you want the pin-up child of hard-leaf, this is a good one. I'll talk more about the fruit and flowering in a second as we get into the project, but I guess I just want to draw your attention to what it looks like. The most prominent thing you'll notice, I guess, is the colour. The colour is quite spectacular. People have said that the nutritional value of the soil can change its intensity of colour. They've seen that. I don't know if has anyone had experience growing it in Perth? A little bit? Yeah. Have you?
I don't think you get the colours in Perth.
Is that right? Yeah, that's what I've heard. Yeah.
Yes.
The Naturalist Club had one in the Netherlands for many years.
Yeah.
We used to get the yellow at the top, but
Right.
we never got the deep red.
Ah, interesting. Because the yellow obviously is the first flush of growth,
Yeah.
and so it's the youngest, and then the deep red. Yeah. Yeah.
It's a sort of paley orangey colour.
Right. Yeah.
It's, 10,
Yeah.
20-year-old plants.
And so this is not unusual for the plant down south. It's this is kind of incredible. It's like equivalent to, I don't know, traffic lights or something. The youngest growth on top, and as you move down. Hakea victoria, or Royal Victoria after Queen Victoria, or otherwise Chinese lantern bush is another name. And you kind of think, oh yeah, okay, maybe this is the lantern, I guess, and they've got multiple lanterns. I can kind of see why people kind of maybe gave it that name. Spectacular anyway. That is my a little bit pitiful version of a Hakea victoria seedling. Tasman is pretty accurate. Yeah. Well, I was going to say, Tasman has already done some germination trials at WA Herbarium. So one of the things we want to do, and I'm going to talk to you about what we've done and what we haven't done yet, or Tasman in particular, and what we're on the cusp of doing tomorrow, And one of the things is she's done some germination trials to try to just work out a protocol for germinating to make sure we're going to use the right temperatures, right medium, on petri dishes. But, you know, how many seeds did you have to start with?
On the actual seed
That trial, no, the first trial. Yeah.
400 and
right.
something.
So 400 plus seeds, and then I'm sure she collected every little seedling, put it in dirt, and tried to propagate them. And some of them came out well. And we took them back down south to friends group and things, and so we might have a few grow on and see how they go. But what I want to explain to you, I guess, through my pictorial kind of version, is that it's just the life cycle. And it's pretty obvious. You start like a small plant, you get larger, and then as it sort of the leaves get older, they start to change colour. I won't mention it in the talk, so I can tell you now that one of the first things we realised is that the leaves seem to last for, I would say, maybe minimum of 4 years, but up to 6 or maybe even 6 years max. 6? Yeah, and so typical of a plant that's hanging onto nutrients. You know, it's poor in the ground, it took me so much effort to collect it, and so now I want to hold onto it as long as possible. So you make a bulletproof leaf, you make something that something's not going to eat, and you hold onto those nutrients as long as you can, and probably, I'm guessing, before the leaf dies, it probably pulls out anything that's mobile and recirculates it in the plant, and it's leaving kind of a carbon skeleton dead on the plant. They don't fall off unless they're knocked or they're burnt off. At some point, they will produce fruits or nuts. If I alternate language, you know what I'm talking about. Hard, woody fruits. The one that's floating around, you realise that this one's open, and so the minute you take a fruit from the plant that is still connected to the mother plant, and I mean sort of, it's still moist because of that, the minute you take it away, within a day or two, it'll actually split open and reveal probably the 2 seeds. I haven't come across less than 2 so far, with a wing, typical of sort of the Banksias and, you know, other Hakeas and so on. The whole thing is probably about the size of my little fingernail. You can see the imprint in that nut as it goes around. But that woody fruit obviously offers a bit of protection against the immediate heat of fire, and then so when the mother plant dies, all of those little capsules open up and the seed falls to the ground. So our knowledge at the beginning of this project was strongly serotinous. In other words, all of that fruit is held in the plant. They don't open until a fire will kill the plant, and then you get this massive seed drop, and that's the next generation that's going to come through and replace those dead individuals. And we were sort of saying no interfire recruitment, you know, because maybe long fire regimes, and it has implications for turnover of plants. And the word that we kind of heard and what we could glean from any kind of comments was that no, it's serotinous. No, it doesn't have any interfire recruitment. It relies on fire to do that. The other thing that we didn't know was how long does it take to get from here to here? Because that, if you like, is I would say that's not even the minimum time that you have to have as an interfire period. Because if that happens soon after, in the first winter after fire, then time ticking along, tick, 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 tick. If you put a fire through now, at best you'll get 1 year, say, of fruit. That's, you know, first fruiting. And so really, we're asking, John, that's good. We're really asking the question of how long before really it might be appropriate to have a fire go through, either prescribed or natural, to allow the population to keep recovering. Since I've got the pretty photo, I may as well run with it. I planned it that way. Here is the plant then. You can see young buds that are going to become flowers, so they'll burst into flower. And down here you might make out, that's the remnant of old flowers that I would say were unsuccessful, so they haven't formed fruit. Otherwise, at this point, they'll probably be green. And then further down, you'd have older fruit. And so as you chase the plant down towards the ground, you have different generations of fruit all being held on the plant. Here is the flower when they open. Tend to be, I suppose flora-based would probably say, I want to say July to September flowering period. We've seen them flower earlier than that. April, yeah. So, you know, but that's just, I'm sure there's a lot of fluctuation. It's a bit of an approximate guide. They're not overly spectacular or anything, but they're kind of pretty defined. They're the softest part of the whole plant. So they're delicate. And if pollination is successful, and I'm guessing from that sort of flower, my instinct is insect. You know, there's not a particularly strong smell, creamy flower, there's nectar in there. mind you, I probably should have to show Byron this and have a good chat to him about it, because he'll be able to tell me far more. But you know, yeah, honey possum around, length of those pollen presenters, stigma as well, might suggest the distance from, you know, the source of the nectar in the animal. Project for another day, perhaps.
And they'll go into prickly plants.
Right, yeah, tiptoe their way through, and they're nice and light, so they're probably thinking they're not prickles. I don't understand. They're just things to hold on to, their little size. Then we've got young fruit here, green fruit, and then that will obviously progress to something older. And as they get older, they tend to get more gnarly as well. So quite soft looking here, they'll darken and so forth. So that's the fruit kind of production. So at that point, one of the things I'm leading to is, you know, let's just ask the question, is there any interfire recruitment? So do any of these fruit open with maybe the oldest ones, split, seed, and then germinate and start to have another generation come through? Literature didn't sort of suggest that that really happens at all. Fire will come along, obviously burn the plant at that point. The mother plant will die. That's, you know, obligate cedar, typical kind of, actually one extreme of the spectrum of what we kind of see in our flora and responses to fire. And then that's when the seed rain will come, as sort of I explained, end up with a whole pile of seedlings, and then the whole thing sort of starts again. There are opportunities, obviously, for predation of seed here. And yesterday, or not yesterday, but recently, Tasman finished going through the 200 and something bags of nuts that we collected last year, weighing seed and looking at quality, and they were bagged according to age, so we kind of knew the age of those fruit, how long they'd been there. And so to picture in your mind, we're kind of talking about the viability of the seed over time. If it's sitting on the plant, how long can it sit on the shelf before the expiry date's up, sort of thing. And also looking for evidence of predation on the plant. But also you'll get predation of the seed that hits the ground, birds and other things, and ultimately predation of the seedlings, and eventually off you go again, around you go. So the questions that Tasman is really a core to her project, and I've left a couple out, and I might refer to them at the very end, are things like, well, how long does it take to reach maturity, reproductive maturity, and start actually producing fruit? Because that's the starting point to measure. Well, here we start to have hope that we could replace a population if a fire came through. But really, you know, every year after that point, you could effectively say, because there's another flush of flowers and fruit, etc., we could say there's another crop of fruit we could add, and there's another crop. How many crops do we need before we've got enough to deal with all the predation and so forth, and you know, the random loss of plants and drought and all the other things that might prevent a seedling going to maturity, and replace the mother population? Second, how does seed production change over time? Does a plant like this produce as much seed as a big mature plant? They get bigger, they get more branches, they get more tips as well. So there's definitely potential for more seed production. Does vigor increase? How long do the plants live for? So if it was unburnt and the area, you know, for 30 years, 40 years, 50 years, is at some point you look and say, well, they're actually all dead now, and the seed is going to fall into an unburnt environment. There might be competition and other things, and it's not good. So we actually might need a fire, you know, at some point, because that's the other extreme. That's why fire is not a bad thing. Fire is actually a critical thing, in my view. And then the interfire recruitment question is also there. That part of the life cycle I've just made disappear is not a focus of the project. It's another honours. There's only so much I could load up Tasman with. Shortly into our honours, you know, she became fully employed, which is very hard when, hang on, Tasman, tell me this again, you've got a full-time job, and honours is meant to be full-time. She goes, yeah, this is such a good opportunity. And, you know, we had this conversation, and then we worked out a plan that maybe we could drag it out over 2 years, and that's what we're working on now. Still challenging, right?
Very.
Right. Yeah, just,
Friendship or a half.
yeah. All right, so they grow very tall. That's taller than, you know, flora base is about this tall. Anyway, so I'm not picking on flora base. I'm just saying, you know, don't read everything you see. No, don't trust everything you see. No, there's more to be learned. I don't know. Here is the park, roughly through here. It's a huge park. We've got sites in the east and sites in the west. The one site I mentioned that's outside of the park, it's not so much a site, although it is, we've collected a little bit of data there, but it's limited, was Tozer's Bush Camp. Robert Tozer, interesting guy. I'll mention him very briefly.
We've actually got our field trip down there in September.
Ah, good choice.
This branch.
You will not be disappointed by the character who is Tozer, as well as the whole landscape. Yeah, yeah. And when did you say?
In September.
Ah, so you're going for orchids, are you?
Yes.
Yeah.
And Paul's leading.
I'm the botanist that does Tozer's tours.
Oh, fantastic. Oh, yeah, so you're all over it. Oh, yeah, yeah.
I know that Hakea Victoria down there very well.
Yeah. Really nice guy. Interesting. Talk to me about sustainable housing as well. Fantastic.
Yes.
So, you know, that's the little park there. This is the chunk here to give it placement. We've got a range of sites, and the main thing to take away from this is that the sites have different times since fire. So they were chosen, the first project basically Tasman jumped into was looking at GIS data to try to identify accessible sites where Hakea Victoria was and with different times since fire, so that we could use it to sort of say, well, this is what it looks like, you know, after, I don't know, 13 years or 16 or 24 and 19 and so forth. The sites were chosen. We didn't have a lot of choice, really, because of also accessibility issues and things. One deviation, sorry. I talk a lot as well, I apologise. I don't want to drag this out. No Tree Hill. There is some history behind No Tree Hill that I need to mention, because this was, in fact, part of the reason why the Friends group said, yeah, we like that project and we'd like to fund that project. So Jill and a few others have been climbing that place. Jill's mother, in fact, has been climbing that place for years. It's right on the edge of the park, and No Tree Hill is just that. You walk for a long time thinking, oh, it's kind of like, you know, it's nice kind of heath and scrub and things, and you're walking through, you get a change every now and then, and you realise, oh, soil change or something going on here, and the vegetation changes. You come across Hakea Victoria after probably, I don't know, I'd say a good sort of 25-minute walk, and it was up there where there used to be a thick stand of Hakea Victoria. And Jill describes, and she actually showed us photos, these are, you know, not digitals, these are old school camera type photos, showing this is what my mother took back, and I can't remember the photo, it was in the 80s, and there was this dense population of Hakea Victoria. And then she said there was a fire in 89, correct me if I'm wrong, and then there was a subsequent fire in 2003. So that's 10, 11, 12, 14 years between fires. And in 14 years between fires, there's been, she looks at the population and says, this is less than half what was there. And you'd look at the photo and think, yeah, right, this is quite thin now. And so for her, that was the evidence to sort of say, it's clear something's going on. Could have been fires, it could have been other things, but it feels like it was the fires being too close together. And 14 years sounds like a bit of time, but obviously not enough. First question. So, when do they become reproductively mature? On our first visit, we went out to Tozer's Bush Camp because we knew he had some Hakea Victoria out there. We didn't know what. And when we met him, really hospitable guy, he basically shot us out and he said, there's two big mother plants. He refers to them as like his babies. He's had a whole career in agriculture and wildflower farming and all sorts of stuff, but he's turned to kind of conservation because that's his passion and love. I think it's always been there. And so he knew exactly where these plants were. He took us to the plants and we said, you know, do you mind if we do some measurements and bits and pieces on them? And before I left, I'd taken a few fruit and he gave me a bag of soil because he said, plant them when you finish the seeds. And, you know, so I was going home with a goodies bag. But that site was useful because he said the fire occurred in October on this date, blah, 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 blah. He knew everything about it because it was his property and he had to put it out and so forth. So he had this intimate history, and the plants, the little seedlings that we mentioned, I say plants, seedlings, you call them what you like, but this thing is in the order of maybe 12 years old, 13 years old. So they don't grow very fast. This is probably a shorter one of the ones that were out there. There were some taller ones. But from that site, we instantly kind of got a sense that probably the earliest time you might start to see fruit is about 7 years. and then thinking back to Jill's No Tree Hill kind of story, 7 years, and then 7 years after that, maybe, if everything's the same, you know, that means 7 years of fruit production isn't enough to replace the population of No Tree Hill. Bit of extrapolation, but that's the gist of the sort of story. I thought I'd throw an awkward photo in just for fun, to tease you a little bit, maybe as a warm-up to the big event. I don't know. That was on the same trip, but it was actually more Tasman who was the driver, because it was a bit out of our way, but we went back there and we said to Robert, you know, I don't suppose, we know you've got Queen Sheba on the property, I don't suppose they're flowering, I don't suppose you want to show us. And he was really keen. We had this chat about his house and everything, and he basically walked us, and he said, we got to a point, he said, stop. He goes, you've got to walk in my footprints. And I said, all right. And we were just like, and then occasionally he would do this. No, but it felt like that. It was like, you know, dump, dump, dump. And finally, and it just amazing, beautiful things. And it just reminds you of how, you know, Hakea Victoria gets something like this. This is so delicate, so, you know, again, charismatic little guys. I don't know. Beautiful anyway. Question 1 and question 2 kind of combined, because our knowledge kept growing. Every time we stepped into that park, we learned something more about the plant. We did a lot of fruit counting, and so not removing, but although we took some fruit, so I've mentioned that. But working from the top, going down, measuring heights. At first, we were just measuring everything we could because we weren't sure exactly what might be important. We had some questions, we knew what we were doing, but some of them we were making up as we went along. I think science sometimes is a bit like that. But we knew we had to count fruit because that was going to be important. And so this is the mean number of fruit per plant at the different sites of different fire ages. So everything has been sort of correlated to when the fire occurred. And so they've been lined up in that way. So time since fire. So this actually represents Tozer's site. Is that right? Is that Tozer? Yeah. So tiny dot, small standard error, which just talks about the variability between the plants in terms of the number of fruit that we got there. And but that's, you know, it was because that was working on the seedlings, and so there were 2 mother plants, but plenty of seedlings around them, so to speak. Dispersal out to about 20 metres. You know, that's the sort of things we learned along the way. And then the other sites. Now, I've drawn this line between these, but I recognise and I deliberately haven't removed this outlier. But from that, it instantly told us a few things. Number one is, you know, at Tozer's site, we used another technique, and I'll talk about this in a moment, to help us extrapolate back in time to try to work out when the earliest fruiting was. But if you take it from the face value of that site, they are fruiting at 13 years. There seems to be kind of like a nice, almost exponential type growth rate of fruit production over time, out to 33 years. A lot of variability up here. It's a large standard error kind of bars. So it's sort of showing that some plants don't all do the same sort of thing, some a bit higher, some a bit lower. But it's showing that they kind of get stronger. And now, my question, and you know, and this is why we've been having this conversation of, we need an older site. Site's been unburnt for a longer time. We know when it was when it was last burnt and so on. So I want to know whether that starts to plateau, or does it just rocket through the roof, or what does it do? Because at that point, it's sort of saying that the canopy, a seed bank, is still growing. It's still kind of growing strong. This is an interesting point because it's made up of sites from sort of 2 different locations. One location looked a bit stock standard, where you might find Hakea Victoria, at the bottom of East Mountain Barren, sort of walk trail. You look around and sort of the plant sizes and their condition looked as we might expect for 16 years and things, quite healthy, vigorous and all the rest of it. And then there was this other site which I probably should take responsibility for leading us into, because we kept driving past, and every time we come into the park I'd say, what about those? Look how dense they are. They're going so great. You don't think we should put a plot in there and we'll get through? We ended up on our hands and knees crawling through the undergrowth trying to get into these places. We couldn't put a plot because we couldn't see each other, so we ended up running a transect and doing other things. And we did some measurements in there. It turns out, my interpretation is, they are the happiest plants in Fitzgerald River National Park. They're growing strong. They fruit like you wouldn't believe. It's a north-facing slope. It's wetter than some areas. Soil samples suggest that nutrition is different. There's actually higher amounts of different things, including iron and stuff. Not phosphorus. I was looking at phosphorus, but these things don't care about phosphorus too much because they've got other ways of getting it, proteoid roots and all sorts of other things. Yeah, right. But it's different, and in fact, choosing that site I think created a bit of an outlier to the data. More sites for 16, maybe an older site. I don't know. No, this is the next visit. Just warming her up. No, I don't know. It has to end someday, right? It has to end in October this year, in fact. So, yeah, there's a lot to go. The detail of that last graph is based on a handful of data points. That's kind of it. They're the points that create our curve, and that's it. And we're thinking, it'd be great to be able to have more detail in between. And this is where, and I'm guessing a lot of you have noticed this, and Byron Lamont, this is one of his drawings, he drew this back in 85, I think it is, from a paper of his, and he used it to age Banksias. So you go to the freshest, youngest growth, and if you look backwards, you kind of find these nodes, these growth nodes, and they represent annual increments of growth. And so if you start at the top, you can walk back and basically age the size of the plant. If it's young enough, you could probably chase it all to right to the ground and say the plant is, I'm sure it's so old. It also means that if this has been an inflorescence, you can go, okay, so this is 23, go back, that's 22, 21, 20. Okay, so that plant flowered in 2020, if that was the case. Based on that, before we went out, Tasman was saying we might be able to use this technique and blah blah blah, and because we'd seen pictures of the plant and thought it's got a very characteristic growth about it, the Chinese lantern kind of effect, right? And so we can see, is this 1 annual growth increment, 2 annual growth increment, 3, 4, and if they're growth increments, then are the fruit that we find here, are they associated with this year and that year and that year? Therefore, if this is 2023, in fact, if I do that. This was for this plant, 2022, 21, 20, we can go back and say, oh, the fruit here was produced in 2020. And so if this site, and it's not, well, probably not, but it was burnt 33 years ago, we can walk backwards down the tree and say, and this fruit was produced 31 years ago and 30 years ago, and keep going back as far as we can until the secondary thickening of the stem and things sort of starts to absorb all those features, and suddenly the pattern disappears and you kind of lose it. But you can go back in time a little bit. So using that approach, we were able to extrapolate a little bit more between those dots and start to look at the curve maybe in a little bit more detail. This tag is on, essentially we went out to the field and put the tag here on a series of plants, came back, was it 9 months?
No, it was 9 months, yeah.
About 9 months, less than a year now. It was opportunistic. We're out there and we decided let's check on them. And so the tag was put there, this was the next year of growth. And so we're kind of validating the fact that the kind of what we think is the obvious, that's an annual growth increment, another one, and so on. And it seems to be exactly as we suspected. This data is now fruit accumulated per plant. And so if you like, adding on the fruit from 1 year to the next, to the next, to the next, to the next, and sort of showing you how the plant might accrue fruit. It's a bit rough and ready. It's not a perfect graph. It's something I was playing with the other day, just to sort of trying to work it. The 33-year-old plants, you can only go back so far and it kind of conks out because you run out of evidence. And so, but then it overlaps with maybe the 24-year-old plants, etc. It does show a similar curve to what we saw with that first graph I showed you. It shows that we still have increasing fruit accumulation. The slope of the line indicates how fast. So this is relatively flat. It actually starts to seem to pick up its gain, from about 25 years. But that is a suggestion that maybe it's just about to plateau, slow down. Plant might be heading towards senescence, winding down a bit, reproduction pulling back, and finally might even be stopping and the plant will keel over in a hot, dry summer or something. The other thing that, and this is sort of, it ties to the seed bank growth over time, because what combats the growth is if you lose seed, but we've already said that the literature says, highly serotinous and they tend not to open seed until they burn, etc. So we're also looking out for open fruits. And it's fairly self-explanatory. You can almost ignore this. This is the inverse of this, but this is the important bit, is that from, again, time since fire, this is the percentage of, we could call it fruits that were open or nuts that were split open and release the seed. So from when they start, they gradually start opening fruit fairly soon on, not many, but up, into maybe 20 years after the original fire, you might have in the order of 20 or 25% of those fruits opening. And so you're starting to have that much seed going back into the environment, which you suddenly think, oh, well, into fire recruitment, maybe this is a thing. 30% at 33 years. What happens beyond this? And I think that's another interesting question. Does it continue in that same sort of trajectory? Or as the plant gets older and maybe a little tougher or secondary thickening starts to kind of trim off, maybe this starts to accelerate. Who knows? Extrapolation, dangerous stuff. We need an older site to look into that. Question? Yes?
The viability of the seed that has opened, do you know how long that seed will stay viable if there hasn't been a fire? If it opened at 20 years, and there's not another fire for 40 years, it's been sitting in the ground for 20 years.
Yes. Well, that's right. Number one is when it falls, does it germinate? And the answer is, I would say it will germinate. They're not long-lived seed. So Banksia, Hakea, they tend to germinate after falling in that first winter. They might survive a year or two. I don't know. I'd have to look at literature. I don't want to step outside.
It doesn't need the fire to germinate.
It doesn't need the fire to germinate, so it's not. And so the fact that the seed is falling to the ground, suppose if it's not being eaten by something, there is all likelihood that it will germinate that winter. So now, then coming back to, well, then what about interfire recruitment? New plants coming in. And this is the way I wanted to think about it is, on the one hand, we might be thinking about how long will adult plants live. So imagine a population, 1 hectare, population of plants in there. If we have some die, it means the capacity to generate seed in that 1 hectare starts to decrease because someone says, I'm out of the game, I could stop producing fruit now. And in fact, it dies. I'm guessing those seed pods will open up, drop seed, if a fire, and I'm talking about if a fire hasn't gone through yet. And on the flip side, the opposite end of the scale is if the seed is dropping in and we're getting new plants coming up, then that'll increase density of fruit contributing plants. So they are important for, if you like, the overall objective is to kind of make an assessment of the amount of seed that is produced over time for Hakea Victoria population. So how long do the plants live? I'm not going to answer that. The data's there, just needs to be kind of crunched and worked. Am I right? Is that? Yeah. But we can say that we've seen them dead in, I know, at least 33 odd sites. What about 24? Off the top of your head, can you remember?
Yeah, there's a couple of dead ones.
Maybe, yeah. So you start to see plants die, and obviously there's all sorts of factors and reasons why they could die. But that'd be a nice graph to show kind of how death is experienced by these plants. Recruitment. So here is an old site, and you can see just from this evidence alone, an old site with a heavily branched, so many tips versus something like this, which is younger. If we use height as a rough proxy for age, every growth, a new Chinese lantern kind of thing, and up it goes. And even if it kind of goes out wide, it tends to still push that way as well as that way at the same time. So I guess a larger plant, larger roots, and maybe more capacity to support multiple tips at the same time. But even in that picture, you've got dead plants, old, mature kind of plants, and then young plants. And this suggests that there's interfire recruitment. These graphs are a little bit small. I made them as big as I could so I could fit them all on the same slide. This is the percentage population. So these are basically frequency histograms. So in other words, height of plants along the bottom in different categories. So 0 to ½ metre, ½ to 1, etc., right the way through to sort of 4 metres at this end. And so this is sort of saying where most of the plants are in what sort of height category. And so at 16 years after fire, so this is our 2006 site, you kind of see that the bulk of the plants are in this sort of 1 metre to 1.5 kind of metre zone. You've got some taller ones, they've kind of bolted and they've got a nicer spot or something like that. You've also got some very small plants, which is that like half a metre? It's like the one at Tozer's. Remember, the kind of the tape measure went up to about probably 40 centimetres something. So it's in that vicinity. So even at that sort of age, it seems like, and remember the opening of the fruit tends to start early and it accelerates to about 20 or 25% and so on. So it's not out of the question that at 16 years, you could probably start to see a little bit of recruitment. 19 years since fire, adding another 3 years, not a heck of a lot of change. I'll point out that the spread of this population is also, I think, a bit of an artefact of, remember that weird site, that outlier? I think the outlier kind of plants are probably the ones more over here doing really well. And then when we kind of batch them together with our other sites, which are a little bit, got a bit tougher over here, it sort of spread the distribution out a little bit more. So here we have, you can see the peak 1 to 1.5, and you'll notice that, you know, there's a decent number here and definitely here, decent number here, same category, but less here and more here. So then basically got taller, makes sense, right? Plants grow up with age, so they're getting older. We've got little plants still. We've got a few hanger-oners here. Are they coming through, or are they just ones that are struggling to grow for hard reasons? I don't know. 33 years, you can see the population has shifted more to that right. They're taller, they're older, they've got spread, still got little coming through. So there's definitely seedlings out there. They're competing with the thickest vegetation you're going to have because, you know, it's been growing for 33 years. So they're doing it probably tough, but there is still a bit of in-fire recruitment. Is it significant to contribute to fruit? Don't know. It depends on how many. Probably a question you'll be able to answer to a degree, and it should be factored in there. But anyway. Does the viability of the canopy store... This is question 5. Do you notice at the beginning I only had question 4? So this is where I kind of tie it all up, and I talk about what's about to come. Does the viability of canopy stored seed change with time? And this is... So imagine that we are totally in control of the fire for where Hakea, Victoria was. Therefore, we could prescribe it and try to pick a natural window. And our goal would be to maximise the canopy seed bank. I think that would be a pretty good goal because it feels like, unless you had a problem of competition and they were just dying because they're too close and things, which I doubt it because there's so many things that want to eat the seed and all the rest of the factors that go against it. We want to find this window of where we maximise seed. But it's not about just having piles of seed, it's having piles of viable seed. And if it meant you pushed into, you know, older and older plants producing more and more seed in this direction, and you look back and further down the plant, the old fruit that is further down that stem, they might have seed and they might not have opened yet, but those seed might have lost viability. They might have been, you know, that's it, end. And so the whole viability is kind of up near the high end, and so waiting any longer for a fire might be a little bit pointless. And if the plants start to senesce, it might actually be the wrong model entirely. And so, you know, finding that sweet spot is kind of at the core of what Tasman's trying to do. I mentioned Tasman ran a germination trial to get the protocol right. Tomorrow morning, apparently, I didn't realise it was just tomorrow morning, down at WA Herbarium working with Andrew Crawford in the seed section. That's where we've had our seeds stored in, you know, dry and cool conditions so the viability doesn't change. And he convinced me of that. I said, are they going to be good for about a year? What if we packed them away for a year? He goes, they'll probably be good for about maybe 100 years, 200 years. He showed me this calculation and I go, all right, I'm sold, don't worry. We'll put it in the method so people know, but I think anybody who understands germination will realise it's not a problem. So she did plated them up on agar, which is basically a substitute for water. We tried some with sponges as well, but the agar was fine. It's nice and easy to work with. The little guys hatch, the little radicle comes out, you know, the cotyledons are in here. The rest, the old seed wing is kind of hanging on, and then they go into soil and they plant. Are you going to plant up the next? No.
Oh. There's a lot of them.
There's a lot to plant. No. It'd be the next honours project. We should back it on and they can look at the strength of the plants and things as well, because obviously a plant's not a plant is a plant. So that is still on the horizon before October. The other thing is that these plants are loaded with creepy crawlies, so as you've got your gloves on, it's good, you know, to avoid things like huntsmen's. But that's not predator of the seed, but there are things that will be in there, boring holes into the seed capsules that we've seen. And so you're fighting against the predators in the plant as well. Not tackling the predators on the ground when the seed is released, but you obviously lose seed in that way. And so Tasman's just finished going through our many bags, each fruit collected from a particular growth increment, bagged separately for one plant, next growth increment bagged separately, and so on. Gone through them all now, weighing seed, looking at sort of the strength of the seed, and also how those fruit look, whether they've got boreholes and rot and things like that. So lots of really good information coming out of that. And that is I guess the other pieces of the puzzle to come. So in a bit of a summary, this is nothing new to you at all. So what makes up large quality canopy seed bank? That's what we're after. The plus adding to this is the seed production and how that changes over time. So that's questions 1 and 2. The interfire recruitment would add, because you're adding extra plants, so you could potentially add to fruit production in per hectare if we're going to work it out in that sort of way or something. So that's kind of question 4, interfire recruitment. Plant death, how long do they live? That's at the other end. Should we be burning now because they're just dying, and let's get the next population coming through maybe. And I'm not advocating for prescribed burning. I'm just sort of, it'd be nice to know, and if so, we know how a population might respond. Loss of viability, okay, that's question 5 I just mentioned, and then question 6, what is the rate of seed predation, on-plant seed predation. Off-plant would be also good, another honours project, PhD. Hey! So, ultimately, what is the ideal length of time between fires for Hakea Victoria? We don't know, and that's what we hope to find out. Thank you.